Good day everyone, my name is Raul Shinga and today I'm gonna teach you about integration. Integration is the process used to find the area under a curve. By an area under a curve, I mean something of this nature, wherein you are all to find the area under this curve, and here it will be A, here it will be B. In this fashion, you have to find the area wherein integration will lie. You're gonna use the formula in this way. The integration at B A as a function, wherein B is the bigger number and A is the smaller number. Another thing that I'm going to talk about is that integration is the opposite of differentiation. By that, I will explain it more on a later stage. In real world, integration is used to determine how much of drug is in the patient's blood under biology. Interesting, right? Okay, so integration is used in environmental science, wherein the scientist will calculate the pollution over time and measure the water flow. Okay, let's talk about the difference between integration and differentiation in this kind of manner. Under integration, let me write inter here. Under integration, we use a formula. Mostly we use this formula for us to differentiate between the two. Sorry about that. Integration of a function will be in this fashion. Let's say it is like this, wherein we will be integrating this function. It will be x to the n plus 1 divided by n plus 1 plus c. That will be an integration. And also, when we come to the differentiation part, let me write in this way, wherein like a function that we are given, it's written as follows: to the n power, and we have to differentiate it. When differentiating it, by the end of this lesson, you have to be able to integrate using U substitution and integrating by parts. Let's look at some of the examples under the U substitution and the integrating by parts. First one is y equals to e to the power 1 over x squared divided by x cubed. So when integrating, first thing that you have to do is to show that you are integrating. The integration of e raised 1 over x squared divided by x cubed multiplied by dx. Now we have to let u. Remember, we are using u substitution, meaning there should be a u that we have to let. Let u equals to 1 over x squared. For u, we have to differentiate it. Even though we are integrating, there have to be differentiation. And du over dx, the reason we are using du is in respect of the u that we have let. Du, let's write this 1 over x squared like this. So now we have to differentiate, du over dx is equals to, remember the formula that I have told you about when there is an exponent like this, wherein we have to use it. It can be x, it can be any number, n minus 1. So in this case, our n is -2. We have to multiply it with the coefficient of a, x, -2 minus 1. Du over dx is equals to -2x to the power -3. Then you multiply both sides by a reciprocal of 1 over dx, which is dx multiplied by dx, then du is equal to, it's equals to -2. Let's write this x in a form of its positive exponent multiplied by dx. And remember that the reason we are doing this, we have to substitute this dx with du of something. Let's do it in this way. Dx is equals to a reciprocal of this, because we have to multiply it, multiply by x cube divided by -2 multiply by x cube divided by -2. Dx, it will be equals to x cube divided by -2 multiplied by du. So in this case, we have to go back to where we were so that we can be able to substitute dx here. So sorry. Let's make it darker. The integral the integral of e to the power u, since we have substituted that with u, x cube multiply by x cube divided by -2 multiplied by du, and this will cancel out and will be left with the integration of e to the power u multiplied by du divided by -2. Let's take out this 1/2 to the other side. -1/2, the integral of e to the power u. Sorry. Now let's integrate. Whenever we are integrating a to the power something, it will always be itself, then plus c, because we are integrating. -1/2 e. Remember that we have let u to be equals to 1/x squared somewhere at the beginning. Then we have to substitute it back, then plus c. This is our final answer. Let's do another example. Y is equals to sin cube x multiplied by cos cube x. Because we are integrating, let's integrate. Integration of sin cube x cos cube x multiplied by dx. But let's first simplify it to be in a certain way for us to be able to integrate it in a simple manner. Sin cube, cube x into bracket. Let's break this one down into cos squared x multiplied by cos x and close brackets dx. This is equals to the integration of sin cube x into brackets 1 minus sin squared x cos x. And remember that cos squared x plus sine squared x is equals to 1. So in this manner we are just simplifying it for us to be able to integrate cube x, sorry, this has to multiply with the inside, then minus sine cube x multiplied by negative sine squared x, both we add the exponent. Sine to the power 5 multiplied by cos, like this. Then don't forget the x. This is equals to let's let our u to be equals to sine x then we differentiate du over dx is equals to cos x. Remember that we have to substitute these, so in each and every case dx has to be equals to something, du divided by cos x. Then let's substitute it back. The integration of u cube minus u to the 5 cos x multiplied by du divided by cos x. This will cancel off this one. Then we'll be left with integration of u cube minus u to the 5 du. Then we integrate in a separate manner like this. Du minus the integration of u to the 5 du. Then integration of u cube will be equals to u to the 4th divided by 4 minus u to the 6th divided by 6 plus c, because we are integrating, equals to, substituting it back, remember that we have let u equals to sine x, gonna be 1 over 4 sine 4x minus 1 over 6 sine 6 plus c. This is our final answer. Okay, the third one that we're gonna do, it's like this. Y is equals to Sorry about that. It's equals to cosec 2x minus 1 multiplied by cot 2x minus 1. So into integration, let's say integration of cosec 2x minus 1 cot 2x minus 1, like this. So we have to let these to be equals to u. Sorry, let u equals to 2x minus 1. So let's differentiate this. Du over dx is equals to, differentiating this using the exact formula that we've been using, meaning it's gonna be x1 minus 1, which is 0, which is 1, sorry, multiply by dx multiply by dx. This will cancel this one and we'll be left with du. It's equals to 2dx. So let's make dx the subject of the formula. Dx is equals to du divided by 2. Dx is equals to du divided by 2. So in this case we have to substitute it back to here. Where there is 2x minus 1, we put u. Where there is dx, we put this here. We put this. So the integration of cosec u cot u multiplied by du divided by 2. So let's take this 1 over 2 to be here, over 2 into the integration of cosec u cot u du. So this is equal to 1 over 2, the integration of this thing here it should be negative cosec. Negative cosec u plus c. And remember that we have to substitute u to its correct format of 2x minus 1 then plus c. This is our final answer. Okay, the first one, let's do an example of differentiation by parts given in function y equals to x multiplied by cos x. So for different integration of by parts, we use this formula. The integration of u dv is equals to uv minus the integration of v du. So in this case, let's let u equals to x and du, because we are differentiating in this case, it's equals to 1. Then dv will be cos that's 3x here. That's 3x here. That's 3x. Then for v will be equals to sin 3x divided by 3. Using this formula, we have to write it like this. The integration of x cos 3x is equals to, with u, you put x. For v, it's gonna be multiplied by sin 3x divided by sin divided by 3 minus the integration of v, which is sin 3x divided by 3, and du, which is 1. We can just leave it like that. Then x sine 3x divided by 3 minus, let's take the coefficient there to be the integration of sine 3x multiplied by dx. And remember, and you can see that here we are still continuing, wherein it will be x sine 3x divided by 3 minus 1 over 3. The integration of sine 3x is cos 3x divided by 3 plus c. This will be x sine 3x divided by 3 minus 1 over 9, which will be positive here because of this negative, cos 3x plus c, and this will be our final answer. Okay, the last one, let's do this one with the function y is equals to pi to the power ln x divided by x for integration of pi ln x divided by x multiplied by dx. We have to let something to be u, so let's let u be equals to ln x. So du over dx is equals to the derivative of ln x, it's 1 over x. So let's make du dx the subject for the formula. Dx is equals to x du. So let's substitute this back to our equation. This will be equals to the integration of pi u divided by x multiplied by x du. This will cancel out this one and we will be left with the integration of pi u du. So the integration of the integration of pi u, it's pi u divided by ln x plus c. So let's substitute back the u. Pi ln x divided by ln x plus c. This is our final answer. So I'm gonna leave you with an activity that you have to do it. To show that you have understood the integration activity. That's the integration of sine 2x divided by cos for 2x multiplied by dx. It's only one activity. Thank you